She's not dead. She's just resting in pieces. Welcome back to the shrine and the dirtiest underbelly of my CNC. As you can see, some repairs are going on in this area. Some items are missing for the oil lubrication system. For those who are not well versed in the realm of CNCs, most of them use flat beds, as you can see here. So this is basically the bed of the machine, and these are the rails, and this entire carriage that moves that y-axis back and forth slides on that ground and machine surface. So there's the servo motor. The servo motor is driving a lead screw, and the lead screw is moving it back and forth. So this is the y-axis, and then this is the x-axis. So you can see the x-axis motor only moves the table left and right, while the y-axis motor moves the left axis, the saddle, and it's a lot more weight that the y-axis is moving. So while I was doing some machining on the rapid moves, I got the Y lag over max error message, which means that the CNC wants to move this table in a rapid fashion, you know, with a high speed for some travel, and it's commanding a certain amount of travel, but the feedback mechanism on the motor is not giving, you know, the proper feedback. So that means something is sticking, something is lagging behind. So I took apart this motor to make sure everything is connected. That was the first thing I thought, and I checked if the encoder is properly secured. You know, the coupling between the motor and the lead screw is properly tightened. And while I was doing so, I came around the machine, and there's the oiler, and the oiler was flashing a error 1 message. So that basically told me that there's something wrong with the oiling system. So here's a picture from the instruction manual. This oiling system that's being used on the CNCs is called Centralized plumbing system. On some of the literature and online, it's being called single line resistance system, or SLR. And what it refers to, it's got a pump somewhere on a machine that feeds the oil into a central line, and then from that central line it's being distributed to all the places where lubrication is necessary. So I'm gonna go and bring it closer, and what you can see here on the back of the machine, there's a line that's coming in from the pump, this line basically, and then it splits into two. So one side of the line will go to the Z gantry, and it's going to create lubrication here on the Z side. So this picture shows here where the lubrication is actually happening. You can see there are 4 ports that are lubricating the ways on the Z stage, and there's an additional one that lubricates the lead screw for the Z. So this one shows the lubrication for the saddle. Basically what we have here, one line, as you can see, one line here is coming in, and it goes to a distribution box, and from the distribution box we have 3 going out, and then there's a connector here, and there's 4 going out here. So these are lubricating the Y or the saddle ways, and they are also lubricating the table ways. You can see there's also one line here that goes to the lead screw, so it's lubricating the lead screw. I think these never been serviced on the machine. If you go online and you look some of the instructions, they say that checking this system for a CNC, if it's running, you know, 24/7 all year, it has to be basically an annual service where the lines are cleaned, and some of these items inside are replaced. So this is the distribution system that I removed from the y-axis, and right here you can see it's the same layout. Okay, try to frame it so you can see. So this is the bottom part basically that's missing on the machine that I showed initially. So you can see a thick pipe is coming in here and feeding this port here, and that is distributing the flow. So these are the different outlets. Okay, so each outlet goes to a different place on the machine. So there are a total of 13 locations. So there are 8 here that are being lubricated, and there is 5 on the Z, which you can see here. So this is the Z stage. Okay, that's the vertical axis, or basically the spindle. So when the oil comes in through this inlet, it is going to go everywhere inside here, and it is going to be pressurized. And so on the outlets we have these metering units. If you look it up, this is like, there's like 10 different names for these little restrictors. These are being called Lube metering units, or metering orifice, or oil fitting flow restrictor, or they're being called as a resistant unit device. So there's so many names for it, but the point is this is basically a restrictor. So this is a fluid dynamics resistance. That's all it is. So on one side you have high pressure, and then it will create some resistance, and then on the other side you have low pressure, and what it does, it is resisting the flow. So just like a resistor, it will resist the amount of something that wants to go through. You know, for electrical it can be current, for fluid dynamics it will be volume flow rate. So why do they do that? Basically, if you would just have a distribution box and you would pressurize one end, then the fluid would go in a path of least resistance. So what would happen eventually is whatever the shortest route for the fluid to go, that's where all the oil would be just coming out. And that's not acceptable, because then certain areas on the machine would have like a flood of lubrication, and then some other areas wouldn't get enough lubrication. So that's why they use this centralized system. So in this restrictor, you can see inside there are some little holes. So what they typically have is some kind of flow restriction, and it can be a stamped steel plate basically that acts as a restrictor. It can also be like a threaded screw stuck inside there, but they also have a one-way valve or a check valve, and then most of them have some kind of numbers stamped on them, and also an arrow, and the arrow typically shows the direction of the flow. So you can see on this side there are these little holes, and then on this side same thing. Okay, so it's hard to tell which one is the business end, and even if you blow into it it's not going to be easy, because you have a resistance against the flow. So these come in 2 different flavors. There's an M8 by 1 millimeter thread. It's either this side or both sides, or you can have a 1/8 pipe thread. Okay, so when you're selecting these, you got to make sure that you know which one you have. So what I did is I went ahead and I found one of these dies. So this is an M8. You can see it's an M8 by 1mm die, and it goes on both sides. I just wanted to make sure I have a die and a set of taps, because I'll have to make some kind of hardware to attach it to my compressor and basically blow out all the lines to make sure that the lines are clean. And you can see it goes on both sides. To make sure the lines are clean, and then what I'm going to do is I'm going to go ahead and replace all the restrictors. So these are available online. I ordered it on eBay from California. So there's 13 pieces. They sold it as a set of 6. So I basically bought 2 sets of 6 and I think 1 or 2 extras. So what you can see here, if I can frame it, it says HSS4. Okay, so that is the designation. The HSS basically says that it's 2 M8 by 1 threads on both sides, and then the 4 basically tells you how much fluid it will able to pass through. And here on this one you can see the arrow. So that arrow shows the flow direction. So you can see that the flow is going from this side to that side. So would you install this on the distributor, it would sit like that. So the flow is going from here and it's being routed out to the individual places on the machine. So if these will get plugged up because the oil is dirty, or because, you know, whatever else, because the plastic is degrading and inside small chunks of plastic in these lines are being, you know, torn off, and then they travel with the fluid, sooner or later they will plug up these little orifices. And basically, despite that you have high pressure on one side, you're not going to have much oil flow on the other side. So you will start starving that side of the machine, and so oil is not going to get to these places. And so what's going to happen, essentially, the machine is going to run on slow moves, but on the rapids, it will not be able to move fast enough. The servo motor is not going to have enough power to move the table with a given speed. And so in my case, the Y stage, which carries the weight of the table and the saddle, you know, that's a considerable amount of mass that the servo motor has to move. And so if there is not good oiling, there's not an oil film underneath, then it will have hard time to move it. It will move it essentially, but you will get an error on the machine side. A couple more things about the oiling system. On the CNCs, almost exclusively, the oiling system is a total loss. So whatever oil we pump through these restrictors into the machine is going to go down to the belly of the machine, and it will flow down into the coolant tank. And in the coolant tank, because the oil is lighter than the coolant, the oil is going to float to the top. It will create an oil film, and so it will prevent oxygen from entering into the coolant, which is, you know, typically water-based. So this will help anaerobic bacteria to grow, and once that happens, your CNC will start to stink. So there's different ways to skim off the oil, or, you know, clean the tank. I don't want to talk about that right now, but that's one of the reasons, you know, this really oil that we use to lubricate the ways, that's one of the reasons why the CNC will sting. They will have that special, you know, CNC smell. Made a device. It only took me an hour. I'm gonna save you from machining footage. This was actually an old connector, one of these plug-in pop connectors that I saved and salvaged. I never threw any of these things, so I just drilled it out. And then I made a piece of brass pipe that has the same thread. You can see it's M8 by 1, so it matches that. And I wanted to braze it in, but you can see it was short, so I just made a longer one, brazed it in, and I've got tape here. So now what I can do is each of these pipes that go out into the machine, I can drive this in and then hook up compressed air on that side and then just clean those out and then listen in, see if it clean and there's no obstruction in those pipes. That tool is going to be used once. I don't see any future use for this one, but I'm off today. It's Friday, and I'm like, why not? So here's the line. I'm gonna hook this up to the line. There's a compression fitting with the pipe. I'm just gonna hand tighten it, hook up the compressed air, and then open it. And you can hear air is passing out through the saddle. So that one is clean. That one is clean. And initially when I open the valve, what you can hear is the oil is gurgling out. It's basically purging the oil and purging the air and getting rid of whatever else is there. So let's try this one. So right there you can hear the oil is gurgling and it's cleaning out the lines. So I'm going to do the rest of them off camera. Here's a test. I machined a new piece here. I just cut M8 by 1 threads on both sides so I can couple it with my previous part. And then here is the restrictor. So we're going to put the restrictor in. Okay, just hand tighten. So you can see once I open the valve, there's not really much of a flow. You can hear the air whistling out, probably because I cracked this here, and also there's a leak at the quick connect. But now watch, if I take this out and I turn it around, so all I did is I flip it 180. When I open it, this just drives me crazy. These are the worst couplers I ever had. Okay, so here. You can hear that air is coming out and whistling. So indeed this part has a one-way valve. It's got a one-way valve, and that is preventing the flow backwards. So oil cannot flow backwards, it can only flow one way. I'm doing another test. What I did is I hooked up the air inlet to the distributor, and you can see I have all the restrictors in. So once I open the valve, you can see air is coming out from all of them. That one, you can see the paper is bowing. So here are these. These are the old ones. So nonetheless, I'm going to go and take them all out and replace them with new ones. Here's the distributor. It's going back to its place. I replaced all the nozzles or restrictors or whatever else you want to call it, and I blow it out with a gun, so hopefully this part is completed for right now. Just want to make sure that there is no foreign objects here when I connect back the pipes. That would be bad. So when tightening these, I have to be a real ginger, because it's easy to break it here, the casting or something else, but care must be taken that there's no leaks. So again, just look inside, see if there's no foreign object, and this can be connected back. This is the last line I need to connect, and you can see these are going to the ways most likely, and then this one is probably going to the lead screw, so that goes in here. And now everything is connected back. So this one is the inlet. So this is the pipe that comes from the other side through the cable assembly and basically feeds in here. So that will be the last one I will connect. First I want to make sure that when the pump is running, it's pumping out oil here. But this is the right side of the machine. You can see the hose here that comes up. That's the hose that comes from the other side. There's the pump, and then the hose comes up here, right there, and then it goes into this T, and then it branches out. So one goes into one of these flexible cable housings, and the other one goes into the other one. So you can see there are two here. So this is the Z stage. Okay, and the Z stage has one of these hoses. You can see it goes into this flexible cable channel, comes down here, and then it ties in basically same way as the other one, and it branches out into 5 places. So you can see the connectors here. So there's 2 here that are lubricating this way, and there's 2 of these on the other side, and then this one most likely goes to the lead screw. So when the oil comes through this one, it's being routed there through these metering valves. It will be distributed into the individual places. So I'm going to take that off and disassemble it and replace those metering valves. The other hose comes down through this channel here and goes into the Y stage, goes under the table to the other side, which I already replaced. So check this out. This is the Z stage, and these 4 basically go to the ways, and then this one goes to the lead screw. And as you can see, the outlets, watch these outlets. You see, these are the restrictors. So we have a restrictor at each outlet. But watch on the inlet. This looks to be a restrictor too. I didn't look yet. I'm going to look, but I didn't look yet. So I'm going to go and open this, and this is just a piece of paper. So you can see there is some flow coming out here, but not much. But watch this. See what I'm doing? I just put this piece of paper here. So I just put that little piece of paper there, and you can see it's not really moving here, it's not really moving there, and there's also a leak here. So watch that bubbling. See that bubbling? That means this is plugged up, and the air has an easier way to come out right there. So I don't think these were ever replaced. So I'm just marking these for no particular reason. I did the same here. The arrows are gone, So I just take a center punch and mark them closer to the outlet side, so then for future reference. Yeah, this one was loose. So this one has a marking on it. You can see there is an arrow. But most of them are wore off. And then on the other side there used to be some marking. Okay, this says HSS and then 3. Okay, so that's HSS 3. So this just really shows how much oil we can push through. Yeah, this one says 2. This one says 3. This one is 3. That is 3. And that is 3. So all the ones on the Z stage are 3, and then this one is 2. So this one goes to the lead screw. So the ones on the Y stage are not readable. This one actually says HSS 4. So this one is 4. That's on the Y stage. Yeah, this one says PSS 4. So the ones on the Y stage are 4. The ones on the Z are 3 and 2. You know what? I can come back in the future and replace these if I'm gonna have any issues. I took one of these old ones and I basically just took it apart and removed the guts. Okay, completely remove the guts. And if you are curious what's inside, so here is another one that I took apart, and this is the outlet side. I marked the outlet side. You can see the punch mark there. So that is the outlet, and this is the inlet. So it's just some kind of ferrule. This is just a ferrule. So this is the inlet, that's just a ferrule that's press fit in there. And inside we have a through hole. Okay, you can see the through hole now. And then this pin is sitting in that through hole. So basically this pin, when I drop it, you can barely see through the light there. And so that's where the oil has to squeeze through. And then on the other side we have a little valve, which is basically just a metal plate or brass plate, and then a rubber, some kind of rubber ring. That's basically the one-way valve. And then we also have this screen. So that is the screen that you can see inside when you look into it. You can see that screen here on both sides. Well, the machine is running and I disconnected the inlet to the Z stage, as you can see, and I just put a cup underneath, so you can see the oil in a cup goes up to the first ridge here. So this is like the 0 ridge, that's the first ridge. So on the other side I did essentially the same. You can see that the input is disconnected. The oil is dripping down because it's the lowest point, and there's a vacuum on the other side. But you can see it's about the same amount of oil came out. Now watch this. This is the pump, and I can go and manually press the feed, and that is gonna pump oil into the system. So basically it goes into this line, and then it's being distributed up in the machine. Watch this meter here. So if you have a CNC and you're pumping oil
and the meter goes up and immediately it comes down, then you have a leak somewhere. Just like right now I have a leak. I just wanted to show you. Watch this. See, I'm feeding, there's pressure in the system, and when I let it go, it instantly falls to zero. I assembled back the feed lines both for the X, Y, and the Z, and what I did is I exercised the pump a couple times, you know, filling up the system with oil. So if you look here on the Z stage, you can see that there's a dab of oil right there. It's coming down. Okay, so we got oil coming out on both sides. Now I cannot look at the Y or X because I have no idea where that oil would come out, but I'm hoping that those areas also got some good oiling. I wanted to show you again, when the hoses are connected, watch at the meter here. You can see when I turn on the feed, see it goes up to 5 and it comes back slowly. So that takes about 5 seconds for it to come back completely to 0. And then one more thing, the golden standard for the whey oil is this Mobile Vactra, and that's what I'm using. That's what everybody recommended. So hopefully that's another successful repair for my machine, and I hope you guys learned something and enjoyed the video. If you like it, please give me thumbs up, and don't forget to subscribe if you haven't done so. See you next time. Bye.